This problem is throwing it back to our one-step equations, our one-step equations, which we do have a foldable for. I'm not quite sure what page it was on, but you can flip there and it will probably help you solve the second half of this problem, because I'm only going to do the first half with you because we will come back to one-step equations as we are reviewing for our final. But, so that doesn't mean that you can't do it right now, because if you did it right now, that would help you. That would only help you prepare for the final, because the final is coming, in December. But I'm only going to do a couple of them with you. I'm actually only going to look at A, B, D, and F. All right? So this question is asking you to match each equation, so match each of the letters, to a step that will help you solve the equation for x. So in other words, to solve for x, you need to get x by itself. All right? So they want to know which steps, so which of these steps you will take in order to get x by itself with each of these equations. So let's take a look at A first. A, we have 3x equals negative 4. Now, in order to get x by itself in this problem, I have to get rid of this 3. Now, I know when there's a number right next to a variable, a letter, there is an implied multiplication. The 3 is multiplying the x. And so in order to get rid of it, I have to do the opposite of multiplying by 3. So I must divide by 3. When I do that, it cancels the 3 out on that side, leaving me with an x, and then my answer would be negative 4/3. But this is not exactly what the problem is asking. It's asking you to identify which of these steps will help get you to this point. Now, if you look at the steps, though, you'll notice that there's multiply, 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 there's some adds, but there's no divide. And that is what we have, that's the language we have been using in order to describe what we did. So let me show you how we can actually solve or figure out which step is going to be the one that we are looking for. All right? So if I have 3x and I have equals my negative 4, I want to show you that dividing by 3 is the same thing as multiplying by 1/3. It's kind of like with the area of a triangle. Multiplying by 1/2 is the same thing as dividing by 2. You see a pattern here. We're multiplying by 1/2, dividing by 2, or dividing by 3 and multiplying by 1/3. It is an intentional pattern. It works with everything in this regard. But let's look at this. Okay, so if I originally divided by 3 in order to get the x by itself, let's try and see what happens when I multiply by 1/3, okay? So I'm multiplying both sides by 1/3. Now, don't get confused. This is a multiplication sign. This right here is our variable, okay? That's not a multiplication sign. That's our x. All right? So in order to do this multiplication, though, with this 1/3, I have to first make everything a fraction. So even though this has a variable in it, this can still represent a whole number. In order to turn a whole number into a fraction, you need to put it over 1. All right? So now that you have all of the involved numbers as fractions, you can go ahead and multiply straight across on both the left side and the right side. When you do that on the left side, you have that 1 times your 3x. So that's just going to give you 3x. And then you have 3 times 1, which is 3. And on the right side, you have a negative 4 times a 1, which just leaves you with a negative 4. And then a 1 times a 3, which gives you a 3. So multiplying by 1/3 actually gives you the same exact thing as if you were to divide by 3. It gives you the same exact looking thing, or the same exact looking equation that we would use to then solve for x by canceling those out and just rewriting it as x would be equal to that negative 4/3. All right? So all in all, this is just to say that the dividing by 3 that we needed to do for A is the same thing as multiplying by 1/3. So is there multiplying by 1/3? Oh, look, there it is. So the number that should go in the box with the A, or the column with the A, is going to be 7. All right, so we have found that A goes with 7, or the step described in 7 will help you get the equation in A to a point where you can solve for x, or get x by itself. Now let's take a look at B, okay? So B, I have a negative 4.5 equals x minus 3. All right, so this minus 3, this negative 3, in order to undo it, quote, undo it. Again, I'm using these air quotes and you can't see them, so I have to write them. In order to undo this minus 3, or this negative 3, I have to add 3 to both sides, which would give me a negative 1.5 on the left and my x on my right. So I have successfully gotten the x all by itself. So the question is asking, though, which step got me to that point. So let's see, I added 3. Is there an add 3 to each side? Oh, there is. Look at that. So the number that should be in the column with B, or in the same column as B, should be number 3. All right, so let's look at D now. We have 1/3 equals negative 3 times x. So again, with this negative 3 being right next to my x, there is an implied multiplication. So that means even though there's no multiplication there, you have to treat it like it is. All right? That's how variables work. Any numbers next to variables, so letters, any numbers next to letters get this implied multiplication. All right? So in order to undo this multiplying by negative 3, I would have to divide both sides by negative 3. But just as we talked about before, where dividing by 3 was the same as multiplying by 1/3, in this case, dividing by 3 is the same as multiplying by a negative 1/3. Now, that negative sign, you can put it right next to the 3 if you would like. It doesn't necessarily really matter, though, as long as it is attached to that fraction somehow. All right, so let me see. If I want to originally divide by negative 3, which I just realized I forgot the negative right there. All right, so if I wanted to divide by negative 3, I know that that is the same as multiplying by a negative 1/3. So do I have a multiplying by negative 1/3? Multiply. Oh, multiplied each side by a negative 1/3. So D is going to match up with 8. And last but not least, we have F, which is 3 plus x equals 8. So in order to undo this addition of 3, or a positive 3, I'm going to have to subtract 3 from both sides, which would give me the x on the left and 5 on the right. So the question, though, is asking what step got me to this point. So let's say I added, or I subtracted 3. But there is no subtract, just like there was no divide. So let us look really quick, though. If I have 4 and I'm subtracting 3, or I have 4 and I am adding a negative 3, these are actually going to give me the exact same answer. Because if you think about it on number line, let's see, 0, 4. If I am adding negative 3, that means I am moving left 3 spaces. So that means 1, 2, 3. that would be at a 1. So 4 minus 3 is 1. 4 plus negative 3 is 1. So this step right here, the subtracting 3 that we did, subtracting 3, I'm going to write over here, subtracting 3 is the same as adding a negative 3. So hopefully it seems kind of familiar from quarter one. Okay, so if there is no subtracting by 3, I need to look for a adding of a negative 3, which is number 4. So F and number 4 go together. All right, so I did those 4 for you. I am hoping that with that knowledge, you can go ahead and finish the rest. All right.